This is a video on exponent properties. This is day one. I want to jump right into this. That B stands for base. It's the base of the exponent. That's what's getting multiplied, and then X stands for the exponent, and that tells you how many times you multiply the base. So if I had, for example, there's three different forms you might see this. One of them is exponential form, and that would be, just say, let's say as an example, 3 raised to the 4th power, and that would be equal to factored form. I'll just put an F for form, and that would be 3 times 3 times 3 times 3, 3 multiplied by itself 4 times. And then you might see, I'll just put SF here for standard form, and that would be equal to, if I take 3 times 3, that's 9, and 3 times 3, that's 9, and 9 times 9 is 81. And so standard form would be 81. Now, there's a few different properties here that we're going to go over. I'm going to start down here in the middle, x to the m times x to the n. That comes out to be x to the m plus n. It feels like there's a lot to memorize here. I'm happy to go over this with you. My name is Mr. Wattups. If you'd like, you can come by my room 1728, or if you're in my class, you already know that. So what does that look like? Here, I've got x to the 7th times x to the 3rd power. That's x to the 7 plus 3, or x to the 10th power. 4 squared times 4 to the 1/2 power is 4 to the 2 plus 1/2, which I could write as in a number of different ways, including as a decimal. 1/2 is 0.5, so that's just 2.5. When you divide like bases, when you're multiplying them, you add. When you're dividing them, you subtract. So this is x to the m minus n. And if we apply that over here, that would be, in this case, y to the, and it's always the top minus the bottom. So y to the 12 minus 9. And that is y to the 3rd power. Over here, I've got a couple different things going on here, because I've got 4 to the 8 minus 3. This 8 and that 3. And then I've got x to the 5 minus 3. And that comes from those two, because those are the like bases, x, and then 8, 4, and 4. And so those are what we would subtract. You want to simplify that. You don't want to leave your answer like that. So 4 raised to the 8 minus 3 is 5, 4 to the 5th power, and then x to the 2nd power. And I can't do anything with that x squared, but I can break that 4 to the 5th power down. Sometimes that's going to be enough to give your answer, like if you're working in derivative. But if that 4 to the 5th, you want to break that down a little bit further, you can go to a calculator and just type in 4 raised to the power 5. This is what that looks like. In case you didn't see it, because it's a little bit off screen. 4 raised to the 5th power, hit enter, and it's 1024. So I might also write this as 1024x squared. And either of those might be acceptable answers. So be prepared to go to standard form if you need to with the numbers. The variables, you can't do anything about that, so that would just be x squared. What happens if you have x to the m times raised to the nth power? One quick way to kind of show that would be if I took 2 cubed and I squared that. What's being squared, the base of that exponent 2, is everything in the parentheses. And so I'm taking, this is equal to 2 cubed times 2 cubed. And then I can apply this rule up here that says when I multiply like bases, I add the exponents. So 3 plus 3, this is 2 to the 6th power. But what did I do with that? Let's see, that this 2 and this 3 to get that 6, and the answer is I multiply them. So x to the m raised to the nth power is x to the m n power, and remember that when you have two variables right by each other, that means they are multiplied. That's m times n. So over here, 7 squared raised to the third power, 7 squared and then cubed, is 7 to the 2 times 3 power, or 7 to the 6th power. And if I take, in this case, I've got 8 inside the parentheses, that's raised to the 1/3 power. And x, the 2 times the 1/3, that's 2 times 1/3 is 2/3. And so you've got 8 to the 1/3 and x to the 2/3. And you can show that x to the 1/3, I don't want to get into it right now, but 8 to the 1/3 can simplify down to 2. So that's 2x to the 2/3. And we can come back to why is it that 8 to the 1/3 is 2. But for right now, those would be your answers. Either of those would work. Let's see. This one down at the bottom, x over y to the nth power. This is pretty straightforward. X to the m over y to the m. So what do I get? If I have 3/4 raised to the second power, or 3/4 squared, that's 3 squared over 4 squared. And then you can simplify that further. 3 times 3 would be 9, and 4 times 4 would be 16. And so that you might show, depending on what the numbers are or how they've told you, you might have either of those as your answer. Now, I'm going to come back to this one because of the negative exponent. Let's take a look at this one up here. X to the 0. Now, anything raised to the 0 power, this is pretty straightforward. Students always want to say 0, but it's actually 1. And there is a stipulation. The base, in this case x, cannot be equal to 0. You cannot take 0 and raise to the 0 power. If you try to do that, if I take 0 and I raise that to the 0 power, it gives me an error. And so that's not something that you can do. All right. But it's pretty straightforward. If you think, okay, I've got this big long number and I raise it to the 0 power. Doesn't matter how big it is 1. Over here, I've got all of this inside the parentheses, and it's kind of scary looking, all that stuff, but it's raised to the 0 power, which means it is equal to 1. All right. X to the minus n. There's a lot of explanations here. I don't want to go too long on this video, so I'm just going to kind of be brief. X to the minus n is 1 over x to the n. You just take it and make it positive when it goes across the division bar. You want to call it a line. If it crosses the line, you change the sign. And so that's going to be that. X to the minus 7, 1 over x to the 7th. 3 to the minus 4 is 1 over 3 to the 4th. And since we've already done 3 to the 4th, we also know that that is equal to 1 over 81. That same thing applies if it's negative. If the exponent is negative in the denominator, when it crosses over the line, it changes sign. So up here, if it's down here, negative. Up here, it's x to the n. It changes the sign. So 1 over here, y to the minus 3, that is the same as y to the 3rd power, y cubed. 1 over 4 to the minus 2/5 power is 4 to the 2/5 power, because it just becomes positive up in the numerator. All right, where does that leave us? Down at the very bottom, we said we'd come back to this one. This is the same as 10 to the minus 2 over x to the minus 2. But we generally don't want to leave our answer with negative exponents. And so I just know that this is going to come up and be positive. This is going to come down and be positive. So up here, this becomes x squared. And the 10 to the minus 2 comes down here as 10 squared. And because it is a number, we can take that 10 squared and evaluate it. That's the same as x squared over 100. 10 times 10 is 100. So you might have this as your answer or this as your answer depending on what you're being asked to give. So pay close attention to what you're being asked to provide.